Hello everyone, this is Amika Mahajan. Welcome to my channel. In this video, we will study case study based questions. Before reading situation or passage given to us, let's go through all the questions first. First question is, write the relationship between V, V1, V2 and V3. Second question, what will be the current through each resistor? Or compare the two values of the voltmeter reading, one across ends X and Y and one across two terminals of battery. Third question is, if the teacher replaces three series resistors by an equivalent resistance of value for Rs such that potential difference V across it and I is current through the circuit, then deduce relationship between equivalent resistance Rs and individual resistances R1, R2 and R3. Now let's read the situation. The physics teacher, Mr. Mukesh, performed an activity in which he inserted a voltmeter across ends X and Y. He plugged the key in and noted the potential difference across series combination of resistors. Then he removed voltmeter from this part and added to terminals of battery. Then what happened? He measured the potential difference across two terminals of battery, let it be V. He took out the plug key and disconnected voltmeter from this also and inserted a voltmeter between X and P to note down the voltage across R1. Let it be V1. Similarly, he measured the potential difference across other two resistors R2 and R3 separately, whose values be V2 and V3 respectively. Let I current passes through the circuit. Now first question, write the relationship between V, V1, V2 and V3. We know that in series combination, what happens? Voltage V across the terminals of battery is divided among all the three resistors connected in series depending upon the value of R1, R2 and R3. So this V will be equal to potential across R1, potential across R2 and potential across R3. So relation will be V equal to V1 plus V2 plus V3. Second question, what will be the current through each resistor? In series, what is divided? Voltage. Same current I flows through all the resistances. So current through R1 will be same as the through R2 as through R3 equal to current drawn out from the voltage source I. Now, second part of this question, or compare the two values of voltmeter reading, one across XY and one across two terminals of battery. XY is, that means across series combination of resistors. So we know that this whole voltage V is divided among R1, R2 and R3, and V was V1 plus V2 plus V3. That means voltage across XY combination will be same as that of applied voltage V. Now last question, if the teacher replaces three series resistors by an equivalent single resistor of value Rs connected to same source of voltage V through ammeter and key, such that same current I flows through this Rs. Now, because we have replaced this series combination by single resistor having same value as that of net resistance of all these three. That means voltage across Rs will be I into Rs according to Ohm's law, because same current I is flowing through R1, R2 and R3 as well as Rs. Similarly, voltage across V1 when I take this circuit will be I into R1. Voltage across second resistance will be I into R2. And voltage across third resistance will be I into R3. We know that this voltage V is divided among all the resistors. So V was V1 plus V2 plus V3. Put all the values. V will be I into Rs, V1 will be IR1, IR2 plus IR3. Because I is same, so I is cancelled out. So what is left? Rs is R1, plus R2 plus R3. So when I put single resistance across this voltage source, replacing series combination of resistors R1, R2, R3, then what I find, net resistance will be equal to sum of individual resistances. That is Rs equal to R1 plus R2 plus R3. Thanks for watching this video. Like, share, subscribe my channel.